Okay, so in this worksheet, we had to solve absolute value equations. And so there are four equations here. And the lessons, when you looked at the lessons or when we did this in class, you remember that, that the first thing you want to do is to get that absolute value expression by itself. So we look at number one, I have the absolute value of 3x minus 5 is equal to 7. And when we first talked about that, I'm only going to do this one, but when we first talked about that was we looked at this simple example right here. The absolute value of x is equal to 2, let's say. And so if I wanted to solve this, then we did this by inspection, because we know that the absolute value of 2 is 2. So one of my solutions is x equal 2. And we also know that the absolute value of a negative 2 is also 2. And so we also talked about the fact that one of the definitions of absolute value is the distance that a number is, in this case, 2 units from 0. So negative 2 is 2 units from 0. 2 is 2 units from 0. So we talked about all of this stuff right here. But one of the things you notice as you went through this was that when you got that absolute value by itself, you then split it into two equations. And both of those equations should no longer have the absolute value expression. It needs to be rewritten without the absolute value bars. And so going back to that definition of absolute value, notice we have a 2 and a negative 2. So these numbers on the outside will always be opposites. Okay? All right, so in number one's the easy one because the absolute value expression is by itself. So what you had to do next is this. You had to say, I'm going to rewrite this without the absolute value bars. Now, one little thing you have to remember, and I don't think, yeah, we have one of those here. One little thing you have to remember, though, is this. Always ask yourself, when I get that absolute value by itself, and I end up with this equation here, am I going to get a solution? Am I going to get one or more solutions? You will if this number, and for us right here, that will always be a number. You won't, for us at this point on this worksheet, you're not going to have variables on both sides. Okay, so just keep that in mind. On this worksheet, you'll notice that you only have variables on one side. So in that case, it makes it easy because then you're gonna look at this and you look at this number right here, and if this number is positive or 0, you're going to get solutions. If this number is negative, then right away there's no work. You're going to say no solution. So for example, we looked at this before as well. The absolute value of x equals negative 2. There is no solution because remember what we talked about here in terms of the definition of absolute value, the distance that a number is 2 units from 0. Well, that's going to be negative 2 or 2. This, if you think about it in here, the distance that a number is negative 2 units from 0, that's not possible because when we talk about distance, we always think in terms of positive terms. Well, that's a negative right here. And so right away you would say no solution. And so then when we get here, right here, I know I'm going to get solutions. So I'm going to go ahead and split it up. Now, when you split it up, remember you should no longer have absolute value bars. So be careful. Don't lose points because you ended up putting absolute value bars here. What you have to say is this. What's inside that absolute value expression, 3x minus 5, is going to equal 7. And then 3x minus 5 is going to equal the opposite of 7. So negative 7. And so now you went from an absolute value equation to two linear equations, and you just solve those linear equations. So you can add 5 to both sides. So I get 3x equal 7 plus 5 is what, 12? And then dividing both sides by 3, I get x to be 4. So there's one of my solutions. And you can check it real quick by inspection. Just check it. 3 times 4 is 12. 12 minus 5 is 7. The absolute value of 7 is 7. All right, over here, I'm going to add 5 to both sides. Combine like terms, I get 3x equals a negative 2. Divide both sides by 3 and reduce, I get x to be a negative 2/3. And so there's your other solution. And again, you can check by inspection. 3 times a negative 2/3 is a negative 2. A negative 2 and a negative 5 is a negative 7. The absolute value of a negative 7 is 7. All right, so that's the work you have to show in number 1. Okay? You start out with absolute value bars. When you split it apart, no longer absolute value bars. Number 2. Number 2, we have 4 times the absolute value of 7x plus 2 is equal to 20. All right, so one thing you got to be careful of, and if you make the mistake in this problem, it's not going to hurt you because you'll still get the same solution. But you got to be careful because these are absolute value bars. So that represents the idea of a function right here, an operation, I guess. Not a parentheses. So if that was a parentheses, then you would distribute, right? Don't distribute this. Now, if you did, you would still get the same solutions, but you got to be careful, all right? Technically, you don't want to use a distributive property. So what you're going to do first is remember, you want to get that absolute value expression by itself. Right now, you're multiplying it by 4, so you want to divide both sides by 4. So the opposite of multiplication is division. So you're going to divide both sides by 4. So the 4's divide out, and you get the absolute value of 7x plus 2 is equal to 20 divided by 4 is 5. Okay? Now at that point, then that kind of looks like number 1. So now you're going to split it apart into 2 equations without absolute value bars. So you're going to say 7x plus 2 is equal to 5. 7x plus 2 is equal to the opposite of 5. And then solve each of those linear equations. So you're going to subtract 2 from both sides. So you get 7x is equal to 3. 5 subtract 2 is 3. Divide both sides by 7. And you get x to be 3/7. So there's one of your solutions. You could check by inspection. Always go back to the original because you could have made a mistake somewhere in here. Whenever you check, always check the original. 7 times 3/7 is 7. I'm sorry, 3, excuse me. 7, I said 3 times 3/7. I meant 7 times 3/7. 7 times 3/7. Look, let me do that on this one. 7 times 3/7. The 7's divide out, so you get 3. Okay? So 3 plus 2 is 5. The absolute value of 5 is 5. 5 times 4 is 20. All right, so what you have here is correct. Subtract 2 from both sides. I get 7x equals a negative 7. Divide both sides by 7. I get x to be a negative 1. So there's your other solution. And you can check it by inspection. 7 times a negative 1 is a negative 7. Negative 7 plus 2 is a negative 5. The absolute value of negative 5 is a positive 5. 5 times 4 is 20. All right, so that's number 2. Number 3. All right, so number 3, we have the absolute value of 6x minus 5 minus 4 is equal to 1. All right, just like the previous problem when we talked about it, we needed to get that absolute value expression by itself. So I needed to divide both sides by 4 because this right here means multiplication. Over here, though, to get this absolute value expression by itself, right now I'm subtracting 4. The opposite is to add 4. So the first thing you have to do is add 4 to both sides. So I get the absolute value of 6x minus 5 is equal to 5. And now once you get to that point where the absolute value expression is by itself, then you write it as 2 separate equations. And I have to see those separate equations, okay? So make sure you show that. Don't lose any points because you wanted to skip steps, because you didn't want to spend the time doing this. You're getting points. So if you're getting points, do the work. So you're going to say 6x minus 5 equals 5. 6x minus 5 equals the opposite of 5, right? Okay. Now we're going to solve for x. Those are 2 linear equations, so you can add 5 to both sides. When I combine like terms, this is 0. I get 6x equals 5 plus 5 is 10. Dividing both sides by 6 and reducing, I get x to be 10/6 reduced is 5/3. And you can check it. Let me go ahead and check it on this sheet right here. So when I check this, just to show you, so x equal 5/3, right? Always go back to the original. Always go back to the original because you could have messed up somewhere around here. Always go back to the original. So the original was the absolute value 6x minus 5, subtract 4, equal 1. So in place of x, I'm going to substitute 5/3, right? So I get the absolute value of 6 times 5/3 minus 5. Whatever that is, I'm going to subtract 4, and I'm hoping that's going to equal 1. So 3 into 3 is 1, 3 into 6 is 2. 2 times 5 is 10. So I get the absolute value of 10 minus 5, and then subtract 4. 10 minus 5 is 5. Well, the absolute value of 5 is 5, right? And then 5 minus 4 is indeed 1. All right, so that's how you check that. And then finally, the next equation, linear equation, you're going to add 5 to both sides. Combine like terms, I get 6x equal, and then this is also 0 in it. Negative 5 plus 5 is 0. Dividing both sides by 6, I get x to be 0 divided by 6. You're expected to know that that is 0, and you're expected to write it as 0. And you can check that one. That one is easy to check. 6 times 0 is 0. 0 subtract 5 is a negative 5. The absolute value of negative 5 is a positive 5. 5 minus 4 is 1. And then finally, number 4. Number 4, you had this. The absolute value of 3x plus 7 plus 4 equal 2. All right, now, you make sure, if you want your full credit, you have to make sure you get that absolute value by itself. So we're going to subtract 4 from both sides, and when I do that, I get the absolute value of 3x plus 7 is equal to a negative 2. And at that point, based on what we talked about in class, at that point you can say there's no solution because the absolute value, whatever value you put in for x, the absolute value of that expression has to be positive or 0. It can never be negative. So right away you can say no solution. But I had to see this. To get full credit, if all you said was no solution, I could not give you full credit because you did not explain. If you do this, at least, I kind of, in a way, know that you realize that the absolute value of this expression can never be negative. It would either have to be positive or 0. Although you didn't say that, I will tend to think that. All right. But what would be a better explanation if you say no solution is you could say, well, the absolute value of an expression can never be negative. It would have to be positive or 0, and then that would be better, right? But this is fine, as long as you said this right here. And we talked about that in class, and we also talked about that in the lessons. All right, so that is it. So that is the key to Equations Worksheet 8.